Today we're doing Module 4, Lesson 8, just going on to the next lesson. And today's learning goal is kind of interesting. It says, I can think of a fraction of a number. Have we learned about fraction of a number before? That's the same as saying 1/2 of 8 or something, right? That's an example. We know also that we can write that as what multiplication equation?
1/2 times 8.
Good. Okay. So we're going to think of that. Is that the same thing as 8 copies of 1/2? Right? Is 1/2 times 8 the same thing as 8 times 1/2? So isn't that the same thing as 8 copies of 1/2? So today that's exactly what your learning goal is talking about. It's thinking, it's seeing how we can go from a statement like that, a fraction of a number, to making copies of that fraction. Okay? And I'm going to show you guys today why, I'm going to prove to you why those are the same thing. It's not the same thing just because your teacher says it is. We're going to see exactly why it's the same thing. Okay? Very good. For these tape diagrams, I've drawn some different tape diagrams, and I want you to answer these 3 questions. What fraction is shaded? So what fraction of this entire tape diagram right here is shaded? Everyone? 1/3 is shaded. Very good. How could we read it as a division equation? Well, we have the entire piece of tape, 12, and it's divided into how many equal sections? 3. So you could divide, that's the division equation. How could we write that as a multiplication equation? Well, 1/3 of 12 is shaded, right? So how can I write that as a multiplication equation? Everyone?
1/3 times 12.
Ah, okay, very good. See the pattern here? Let's try it again. Let me make this small, and let's try this one. Oh, it's very big. Okay. What fraction of the entire thing is shaded? 1 section out of how many? 1, 2, 3, 4, 5, 6, 7. So 1/7 is shaded. Good. How can we write it as a division equation? We take the entire piece of tape, which is how much? The entire piece of tape, which is how much? 28. And we're dividing it into how many equal size sections? 7. Okay. So if this is 1/7 of the entire piece of tape, which is 28, 1/7 of 28, how could we write it as a multiplication equation? Ananya? Good. So do you see how one tape diagram can show 3 different equations? Well, they're all the same value, but do you see how that works? Okay, let's try one more. Okay, what about this one? What about this one? What fraction of the entire diagram is shaded? 3 pieces are shaded out of a total of how many? 1, 2, 3, 4, 5, 6, 7. Good. Okay. Now, how can I write this as a division equation? Well, I have to take the entire thing, 28, divide it by 7, and then multiply that by what? 3. Because if I divide 28 by 7, I'll find one of those, and I have 3 of them left, right? Does that make sense? So that one's kind of tricky. That's why I did it. How can I write this as a multiplication equation? If I'm finding 3/7 out of the entire 28, how could I write that as a multiplication equation? Ani? 3/7 times 28. Very good. So once again, we can see that tape diagrams are very powerful. This tape diagram in red could represent the fraction 3/7. It could represent 28 divided by 7, which would give us 1 unit, right? And then multiplied by 3 to find the shaded area. Or we could write it as a multiplication equation, 3/7 times 28. When we see this multiplication equation, 2/3 times 6, we know that how can we read that expression? We can say it's 2/3 of 6. Do you agree? Go ahead and write that down. Now let's solve it using the way we know yesterday, okay? We know that we can draw a piece of tape right here, and the entire piece of tape is 6 because that's our whole number. We have to divide it into 3 equal units because that's the denominator. It's telling us the units. And we can draw our question mark to show that in the end, we're trying to find what 2 units are worth, right? So in this equation, help me finish this. 3 units equals what number? 6. So then 1 unit, I have to divide the 6 into how many equal size pieces? 3, right? So 6 divided by 3, which is what? 2. But in the end, we're trying to find how many units? 2 units. So 2 units would be 1, that's what 1 unit is worth, times 2. Do you agree? Which is 4. So therefore, we can see that 2/3 of 6 is equal to what? 4. Now, what if I switched that equation around? What if I wrote this as 6 times 2/3? Is that okay?
Yeah.
Wouldn't that mean that that's 6 copies of 2/3? So wouldn't that be 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3 plus 2/3, 6 times? And we know that when we have 2/3 plus 2/3, what do we get? 4/3, right? Plus another 2/3 is 6/3. So is that the same thing as writing it like this? 2 plus 2 plus 2 plus 2 plus 2, 6 times over 3? And when we have this, isn't that 6 times 2? So isn't this 6 times 2 over 3? Let's solve it. What's 6 times 2? 12 over 3. Can we simplify that? What's 12/3? 4. Huh, interesting. Did we get the same answer both ways? Yeah. If we're doing the tape diagram, we draw a piece of tape, and the entire tape is worth how much? 10. The denominator tells us we need to split it into how many equal-sized sections? And the numerator tells us in the end, we're trying to find how many of those sections? 3. So mark out 3. And the point of doing that is so you don't forget at the end to find what 3 units is worth, right? Okay. Sometimes I even like to lightly shade it in so I remind myself, like that. Okay, now how many units do I have altogether? Okay, so 5 units is equal to 10. Now if I had 10 but I split it into 5 equal groups, what division equation is that? 10 divided by? 5. Good. So 1 unit, I can find 1 unit by splitting my entire piece of tape into 5 equal-sized portions. So 1 unit is equal to what? 2. But remember, I drew that question mark and shaded it in to remind myself that in the end, I want to find how many units worth? 3. So in order to find 3 units, I have to think, okay, well, 1 unit is 2, and I want 3 copies of that. So then 3 units is equal to 6. Go ahead and write that down. So therefore, 3/5 of 10 is equal to what number? 6. Good. Okay, now on the other side, remember, we're thinking of it not only as a fraction of a whole number, but copies of fractions. So do you guys agree that 3/5 times 10 is the same thing as 10 times 3/5? Yeah. So that means it's 10 copies of 3/5, right? How would I write 10 copies of 3/5? Well, I go 3/5 plus 3/5 plus 3/5. How many times? 10. Good. Okay, you can go like this. And then show that it's 10 times. If you have enough room, you can write it out, okay? Now, if I want to write that as one big fraction, wouldn't it be 3 plus 3 plus 3 plus 3, 10 times over 5, right? Do you agree? So instead of doing 3 plus 3 plus 3, repeated addition is the same as what operation, everyone? Multiplication. So if I'm doing 3 plus 3 plus 3 plus 3 plus 3, 10 times, that's the same as what multiplication equation? 3 times 5. But be careful, don't forget your denominator. Oh, sorry, 3 times 10. Thank you. Don't forget your denominator, though. We need to make sure we keep it. If we don't keep it, does the value stay the same? No. Okay, so keep in mind, I want you to really notice that we have this denominator here, which became here, which became here, right? Okay, now we can solve it. What's 3 times 10? 30. And what's our denominator? 30 over 5 is the same thing as 30 divided by 5, which is what number? 6. So do we get the same answer both ways? Yep. Very good. So instead of thinking of this as 7/6 of 24, we can think of it as 24 copies of what fraction? 7/6. Very good. Now we know that that's going to be 7/6 plus 7/6 plus 7/6. How many times? 24 times. Which is going to be the same as 7 times 24 over 6. Do you agree? Right? Do you see how we went from 7/6 plus 7/6 plus 7/6? Because it's going to be 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7. How many times? 24 over what denominator? 6. So I can just write the multiplication, which is like a shorthand or a shortcut for repeated addition, right? Now, does anyone know what 7 times 24 is off the top of their head? No. So we can look for common factors to help us. Okay? Now, 7 is a prime number, so it can only be multiplied by itself in 1. So we don't have any factors. But what are some factors of 24? 4 times 6. Do you agree? So is 7 times 24 the same thing as 7 times 4 times 6? Yeah, because 4 times 6 is 24. Now, do you see any common factors in the numerator and denominator? 6. That means that we have, this is the same thing as, I'm going to divide it by 6 over 6. That means I can cross these out and they become 1s. Why do we like 1s when they multiply? Yeah, okay, so you always have to cross out, if you're going to divide, you have to divide it by the same factor in the numerator and the denominator. If you don't, you're changing the value, right? 6 over 6, what's the value of that? 1. Can I divide by 1? Does it change the value of my multiplication or division when I divide by 1? No. Could I divide by 6 over 3? No. Because that's not 1. Okay, so you have to have common factors in the top and the bottom. So now I have 7 times 4 times 1 over 1. Is that way easier to do? What does that equal? 28. Therefore, it's a lot easier to find that 7/6 of 24 is 28 by looking for those common factors rather than multiplying 7 times 24. Do you agree? Yeah. Okay.